So we continue doing. So we have another set of problems here. So we're going to solve them. So you have the root x plus root x over x is equal to 1. So for this one, this is a combination of surd and indices. So you have this is the same as saying so this is the same as saying 1. Okay, root x this is saying like 1 root x, so it can be written which is equal to root x plus root x is equal to 2. So remember you have the coefficient here, which is 1 for both root x. So 1 plus 1 is 2. So 2 root x over x is equal to 1. So we cross multiply. So to get 2 root x is equal to x. So this one can be written as this one. Okay. So from here now you can say you can do away with this root here by squaring. So you get 4 root x 4 root x squared. So this one goes, so this is the same as this power a half. So 4x, so because the square root and the square goes, then you get is equal to x squared. So you divide both sides by x. This is x, sorry. So the x goes, then this one, the one x goes, so we remain with x here. So you get x is equal to 4. This is x is equal to 4. Okay, yes. For the second one, so this one we have 2 raised power x plus 1 is equal to x plus 3 raised power x plus 1. Okay, so we're going to separate this one to get 2 raised power x dot 2 raised power 1 is equal to 3 raised power x dot 3 raised power 1. Okay, so for this case now we want to put the like term together, so the x's and the other number. So you can divide both sides by 2. So you remain with 2 raised power x is equal to 3 raised power x dot 3 over 2. So this one now you want to put the like term together. You can divide both sides by 3 raised power x by 3 raised power x. Okay, so now to have 2 over 3 into bracket x. So remember you have the same powers here. 2 over 3 is equal to, now this one and this one goes, is equal to 3 over 2. Okay, now for this one to have the same base, this is 2 over 3, this is 3 over 2, but you can there's a way we can do this one to have the same base. So how do? You just do the reciprocal. We reciprocate this one. So for example, if you decide to reciprocate this side, so you have 2 raised power 3 or 3 over 2, sorry. So you have 3 over 2. So you do the reciprocal. So the reciprocal is 1 over. So 1 over this one is like having the negative 1 times x, which is x, is equal to 3 over 2. So remember this is the raised power 1. Okay, now we have the same basis now. So we can now equate the exponential. So negative x is equal to 1. So x is equal to negative 1. And you can check. So you can check from here whether this one satisfies, whether x is equal to negative 1 satisfies. So you can just say what? You can just say 2 raised power x plus 1 is equal to 3 raised power x plus 1. So having our x is equal to negative 1. So negative 1. So this is negative 1 plus 1, 0. So 2 raised power 0 is equal to negative 1 plus 1, 0. So 3 raised power 1, 0. So any number raised power 0 is equal to 1. So 1 is equal to 1. So x, it satisfies. X is equal to negative 1. Now the final one for today, we have x raised power x is equal to 2 raised power 2x. Okay, so for this one, so we have to expand this one. So this one can be written as x raised power x, x raised power x is equal to, this one can be written as 2, this is the same as 2 squared into bracket raised power x. Okay, so that we can have 4 raised power x. Okay, so at this juncture now we can introduce log, whereby we use the, okay, we can introduce log x raised power x, log x raised power x is equal to log 4 raised power x. Okay, so remember here we can use a row of indices or of logarithm that says log into bracket a raised power b is equal to, can be written as, then you put this power on here to be b log a. So we're going to use this one. So you have x log x is equal to x log 4. Okay, so now having that one now, you factor, now you put the right term together. Now we have what, x, we have what, x log x minus x log 4 is equal to 0. So factor out x here, so you get x into bracket log x minus log 4, okay, is equal to 0. So for our first equation here, so meaning if you have either this part here or the whole of this part here, is one of them is 0, because this one is a multiplication here. So whereby a times b is equal to 0, so you can say either a or b can be 0. You get, because any number multiplied by a 0 is 0. So it doesn't matter what kind of number it is. So you're saying either x or this one here, one of them is 0. So that to give us the, because on the other side is 0. So for the first equation here, we can deduce that x is equal to 0. The first equation here, x is equal to 0. That is 1. So the other one, log x minus log 4. Log 4 is equal to 0. So you can equate them, is equal to log 4 is equal to log 4. Okay, so having this one now, so since the base are the same, so you take the log as the same base, so you can say the log and log goes, so x is equal to 4, and you can check whether it will give you the same. So remember, you have seen the first x is equal to 0, so check. So let's use one more minute to check here. So we have x is per x equal to 2 is per 2x. So with x equal to 0, with x equal to 0, this is 0 is per 0. 0 is per 0 is equal to 2. 2 times 0 is 0, so 2 is per 0. So any number is per 0 is 1. 1 is equal to 1. Okay, so it satisfies x is equal to 0. Okay, so x is equal to 4 for this part here. So let's check. 4 raised power 4 is equal to this one now. So remember here, there's a part here we said, where is it? Oh yeah, there's a part here we said this part here can be written as 4 raised power x. So 4 raised power x. So what is our x? 4. So remember, you have taken this part here, x is equal to raised power 4, and you have seen for the x raised power is equal to 4 raised power 4. So 4 raised power x, so you have 4, then our x is 4, so we get 4 raised power 4 is equal to 4 raised power 4 is equal to 4 raised power 4 raised power 4 is equal to 4 raised power 4. So it satisfies that x is equal to 4. So x is equal to 0 or x is equal to 4. Okay, yes. So I think those are enough for today. So you can just check around them and see. So goodbye.